Hello guys, here we are again with the lecture on hypothesis testing using t-test in Excel. Of course, before doing the hypothesis testing, we need some data to be utilized, such as this one. I have here a results of periodic exam of section A and B, of which section A, as you can see, is recording an average, class average of 89.50, while section B is averaging 88.34. So, with these results, we might be interested to know if section A is really performing better than section B, or what we have in mind to compare these two sections is there a significant difference between the class performance of section A and B. So, by the way, t-test is being used if we are dealing with a sample of only 30 and below. If the sample that we need to analyze is 31 and above, or shall we say more than 30, it is not appropriate for us to use the t-test. By the way, this is another topics that we have not covered during our classroom discussion to COVID-19. So, given this problem, how do we now perform the t-test? But before we perform the actual t-testing, let me just briefly overview to you the basic concepts, procedures, and steps on how to perform t-test. Step 1, we need to state the hypothesis. So, in here, as you can see, we are stating this hypothesis. There is no significant difference between the mean of section A and B. Mean, we are referring this mean to the classroom performance of the section. So, this is actually the null hypothesis. We also have the alternate hypothesis. And this alternate hypothesis is just to contradict the null hypothesis. And we will be utilizing this one later when we are determining our decision ruling in the later part. What we actually test is the null hypothesis. So in hypotesting, we can ignore the alternate hypothesis. Okay, so that is step number 1. Step number 2, we need to state the level of significance. So this is the level of confidence. At alpha 0.05, this is actually the widely used assumption for alpha level. This means our confidence on our conclusion is at 95% sure. Other uses this alpha level as 0.01. But at any rate, usually problem does not come with an alpha level. So we need to assume. And this 0.05 alpha is the global standard level of significant assumption. Okay. So step number 3. For step number 3, we need to determine the degrees of freedom. So what is this degrees of freedom? Degrees of freedom is simply equals to the number of item minus 1. In our case, the number of items that we have is 30. So that means n is equals to 30. If that is subtracted by 1, our degrees of freedom is 29. But to demonstrate further, I have here 4 items. Just to demonstrate how can we visualize what is degrees of freedom. Say you are offered these 4 fruits. You have the apple, the mango, the pineapple, and the banana. If you are offered these 4 fruits, that means your n is 4. Subtracted by 1, that gives us 3. That means freedom of choice is only 3 because that is n minus 1. So, further, I have another example. If you are only offered 1 item, such as an apple, such as this one. So, what is your degrees of freedom now? Your degrees of freedom is 1 minus 1, that is 0. That means, if you are offered only 1 item, you have no choice. So, your degrees of freedom is 0. No choice. Only 1 item is given. Okay, so that is how we visualize degrees of freedom. Step number 4. Step number 4, we need to state the decision ruling, such as this normal curve, as you can see. So, this normal curve is being utilized to determine whether our null hypothesis is accepted or rejected. This is a two-tails demonstration of normal curves wherein the white area at the middle is the acceptance region, while both tails at the right side and on the left sides, both of equal value and amount, these are the rejection region. That means any computed value of t that falls within both ends of the shaded portion of this normal curve, we will reject the null hypothesis. But if the computed value will fall within this wide white area under the normal curve with respect to this horizontal line, that means we accept our null hypothesis. But this is two tails. In our case, we will yet to determine which type of normal curves we are using, because we also have the tail to the right test. So we have one tail test to the right. It depends on the problem that we are trying to test. So another is we have on the left tail. That is if we are going to the negative way of testing. Okay. Next, step 5. Step 5, we need now to calculate the test statistics. And that is based on the given data for the hypothesis testing. But before we calculate, we need to determine which of the decision ruling that we presented a while ago is to be utilized. We have this type of problem. From this, we can now determine the type of curves as our decision ruling. So this is, if you can recall, this algebraic expression is indicating that the mean of A, which is 89.50, is greater than the mean of section B. So from here, we can determine which of these, the two tails, the tails to the right and the tails to the left. Okay, so for that problem, we will be utilizing these tails to the right. Okay, so now we will go to step 6 before we calculate to complete the procedures, the steps. Number 6 is we need to compare the computed value of t with respect to the critical value as we mentioned a while ago. Then step number 7, we will state our conclusion. So, now we have completed the simple 7 steps in t-test. We will now go to calculation. Go back to step number 5, wherein we will be calculating the t-test based on the given data. This was the given data. By the way, it doesn't mean if section A is 30, section B is also 30. It only happened I choose 30 students for each section. So we have this data, and I have linked my data to my Excel file. And I will click this one to go to my Excel file. This is the data source, my Excel file. And as you can see, I have here the normal curves that we agreed a while ago that we will be utilizing, because our problem shows that this value of mean for A is 89.5, that is bigger than 88.34. That dictates us to use these normal curves. One tail to the right. So here we go now. Simply click this data on your Excel. Click. As you click, you can now see this button, data analysis. So as you can see this data analysis on your screen, simply click this one now, then find the stat tools, the t-test. We are testing these two data sets that we assume an equal variance, given that the mean is not equal. So we are here, t-test with two sample assuming an equal variance. Okay, so then click OK. So as you can see, there are variable 1 range and variable 2 range. So for variable 1 range, this will be our first data set. Click from this tab, then drag down to the last number of student. Do not include the mean, just up to the last number of student. Then we have this now automatically supplied by the system. The next is click on in here, click in variable 2 range. Once you see the cursor blinking in this cell, we can now click on your next data set, which is section B. Click, then drag down the same way what we did in section A, just up to the last student. Okay, and this is supplied by the system. Okay, now we have the hypothesized mean difference. This will be inputted by us manually. So what is the value? Based from our null hypothesis that says there is no significant difference between the mean of A and the mean of B, that means the assumption for the mean difference is 0. If there is no significant difference, if we assume that there is no significant difference as we declare in our null hypothesis, therefore this must be 0. Okay. This is always be the case. Once your null hypothesis, which is also be the standard one, says there is no significant difference, that means this will be 0. Okay, now do not forget to put a check mark on these labels on the box. Just simply click on this, the check mark would appear. Okay, as you can see, this alpha label, significant difference, has been already supplied by the system. As I have said a while ago, this 0.05 is usually the widely used and globally standard assumption for the level of confidence. Okay. So what next? We are almost done now. As you can see, what is default is here the new worksheet ply. That means if you click OK now, your output table will appear on the other worksheet. So simply click this output range. In my case, I would like to choose this output range and then click in this cell. Once you see your cursor blinking in here, we can now find where do we want to put our output table. It could be here, it could be here, it could be anywhere as you click. So in this case, I would like to put it here. And we are now done. If I click this OK, now it is done. So I will now click OK. Here we go. Just like magic. Okay. So we now have all the value. I will just expand this cell to widen the space so that everything in it will be accommodated. And then let me just put this grid line to emphasize. Okay. So we will now repair to this decision ruling. We have now the test statistics. I will shade this one with yellow to emphasize and color it red for us to emphasize, then bold. Okay. So the test statistics shows that the value of computed t is equals to 0.09326. Okay, we can reduce all this value into 3 decimal places by clicking this one. Click, then every click you do, it diminishes. It reduces by 1 decimal places. So all now in 3 decimal places. And we are, as we said, in one tail. So this is negligible. It should be the one tail. I will also shade this one with yellow and color it red. So and make it bold. Now, this is the two value that we need to compare. So referring to this normal curve here, we will be comparing this value, the 0.09, with respect to the critical value 1.683, as you can see here. So this is taken from the table. Likewise, the system is providing us with the same value coming from the table. Okay. And this value has something to do with the alpha level and the degrees of freedom in the case of t-test. So we will now compare. If we plot this value to this normal curve, this is what? The computed value of t, as we can see, is 0.933. Okay. So where is this on the curve? If this is 1, if this red one is 1, and this is 1.63, I think more or less 0.9 is just somewhere here, right beside 1. Okay? Just here, more or less. Not exactly. But this is more or less. So this is now the computed value of t. As you can see. So this one, the computed value of t. Now, how do we now make our conclusion? So the conclusion is, since the computed value of t, which is 0.933, falls within this acceptance region, the null hypothesis is accepted. I will repeat. The conclusion is, since the computed value of t, which is 0.933, does not exceed the critical value of 1.683, and this falls within the acceptance region. Therefore, we accept the null hypothesis. What was our null hypothesis? It says there is no significant difference between the mean of A and mean of B. Or shall we say, there is no significant difference between the class performance of Section A and Section B. Hence, Section A does not make any difference. Section A does not make any better performance compared to Section B. This implies if the same type of exam will be repeated over and over again, there is no assurance that Section A will be higher than Section B. This also implies that these results, which displays that A is higher than B, is only by chance. This does not mean, in as far as this data is concerned, this does not mean that A is performing better than Section B. Our conclusion, therefore, both sections are performing on the same level. Section A does not make any better than Section B in as far as these results is concerned. Okay, so that's all, guys. Until next lecture, keep safe, stay home, God bless, and let us all help our government fight this COVID-19. God bless once again.